Question 9, Part B. The triangle ABC has a right angle at B, angle BAC equals theta and AB equals 6. The line BD is drawn perpendicular to AC. The line DE is then drawn perpendicular to BC. This process continues indefinitely as shown in the diagram. Part 1. Find the length of the interval BD and hence show that the length of the interval EF is 6 sine cubed theta. I've recreated a part of the diagram for visual reference. As we can see, we're dealing with a set of similar triangles that are getting smaller as we go from right to left. Now, we don't need to prove that the triangles are similar, and the question's not asking for a formal proof. But it's interesting to note that sides AB, DE, and so on, the verticals, are parallel to each other by virtue of the right angles here, here, and so on. But also BD, EF, and so on are also parallel to each other by virtue of the right angles here, here, and so on as well. So that gives rise to alternate angles appearing. So this angle here equal to theta is equal to this angle here, which is equal to theta, which is equal to this angle here, which is equal to theta, and so on. Let's consider triangle ABD. Now, AB is the hypotenuse of triangle ABD, and the side opposite theta is side BD. So sine theta is equal to BD divided by 6. Now, it's regular right angle trigonometry because we're dealing with a right angled triangle here. Rearranging this equation to make BD the subject, we get BD is equal to 6 sine theta. So we have this length here, which happens to be the hypotenuse of triangle BDE. So let's consider triangle BDE now. Sine theta is equal to opposite divided by hypotenuse. The opposite side to angle theta is ED or DE. So sine theta is equal to DE divided by 6 sine theta. Rearranging this equation to make DE the subject, we get DE is equal to sine theta times 6 sine theta, which gives us 6 sine squared theta. Now let's consider triangle EDF, and we'll repeat the process one more time. This angle here is angle theta. Side DE or ED is the hypotenuse of triangle EDF. Again, using regular right angle trigonometry, sine theta is equal to opposite over hypotenuse. So sine theta is equal to EF divided by 6 sine squared theta. Rearranging this equation to make EF the subject, we get EF is equal to 6 sine squared theta times sine theta, which gives us sine cubed theta, of course. Therefore, EF is equal to 6 sine cubed theta as required. Part 2. Show that the limiting sum BD plus EF plus GH and so on is given by 6 sec theta tan theta. From part 1, BD plus EF is equal to 6 sine theta plus 6 sine cubed theta. Continuing the pattern, BD plus EF plus GH plus IJ and so on is equal to 6 sine theta plus 6 sine cubed theta plus 6 sine to the power of 5 theta plus 6 sine to the power of 7 theta and so on. Factorising out 6 sine theta from all the terms of this series, we get 6 sine theta times open bracket 1 plus sine squared theta plus sine to the power of 4 theta and so on, close bracket. Now inside the brackets we have a geometric series where the first term is 1 and the common ratio is sine squared theta. Now we're assuming that the absolute value of the common ratio sine squared theta is less than 1, such that the limiting sum of the geometric series exists. We don't need to find the value of theta, of course. We just need to assume that the limiting sum of the geometric series exists. Now the first term a is equal to 1 and the common ratio r is equal to sine squared theta, as I've stated earlier. And we need those when we apply the limiting sum formula, S infinity equals a over 1 minus r. So applying the limiting sum formula, noting that we have 6 sine theta as a multiplying factor, so we have 6 sine theta times the limiting sum of this geometric series. So we're multiplying 6 sine theta by 1 over 1 minus sine squared theta. Now 1 minus sine squared theta using a Pythagorean identity is equivalent to cos squared theta. If if you recall, cos squared theta plus sine squared theta is equal to 1. And if we rearrange that, we get 1 minus sine squared theta is equivalent to cos squared theta. So S infinity is equal to 6 sine theta times 1 over cos squared theta. Now 1 over cos squared theta is equivalent to 1 over cos theta times 1 over cos theta. So I'm going to split this denominator up. I'm going to express S infinity as 6 times sine theta over cos theta times 1 over cos theta. Now sine theta over cos theta is equivalent to tan theta, and 1 over cos theta is equivalent to sec theta. So S infinity is equal to 6 tan theta sec theta. And because we're multiplying all the terms, and multiplication is commutative, we get S infinity is equal to 6 sec theta tan theta. Therefore, the limiting sum BD plus EF plus GH and so on is equal to 6 sec theta tan theta as required.